Hello all. Uh, In this session, we will solve all the questions that have come from analog circuits in 2020 GATE examination for electronics and telecommunication branch. Okay. So there are 8 questions, right? 3 are of 1 mark and 5 are of 2 marks. So total 13 marks have been asked in 2020 from this particular subject. Okay. So let us solve each question one by one. So the first question is, the component in the circuit shown below are ideal. That means the op-amp is ideal. Okay. The op-amp is having positive feedback. That you could see from output to positive there is a feedback. Okay. And the input is a sine wave of amplitude 1 volt. Then we have to know the behavior of output voltage. Okay. So guys, first thing is should know, since it is in positive feedback, right? And op-amp is ideal. Okay. So what is the meaning of ideal, guys? Gain of the op-amp is equal to infinity. Bandwidth is equal to infinity. The input resistance is equal to infinity. The output resistance is equal to 0. Okay. So it's a very ideal. Okay. And first thing is, when in positive feedback, the op-amp behaves like a comparator. What is the meaning? If V positive, that is potential at the non-inverting terminal, is greater than V negative, that is the potential at the inverting terminal, then my V out will be positive V set. Here it is equal to plus 5 volt. Okay, this is the first condition. The second condition is, if my V plus is less than my V minus, okay, that will give me my output voltage is equal to minus V set is equal to minus 5 volt in this case. Okay, this is the behavior of my op-amp when is in positive feedback. Okay, so now the thing is, initially when I switch on, right, I don't know the potential of positive terminal. Let's the potential be Vx. Okay, this node I'm naming at X. Okay, so I don't know anything about my potential here. So let's assume that my output will be either plus 5 volt or minus 5 volt. You can assume anything, right? So let us assume, after switching on, let us assume that V0 is equal to plus 5 volt. Okay. So if my V0 is plus 5 volt, right, then at what point it will come to minus 5 volt? Like, what my question is, suppose after switching on, if my output is plus 5 volt, then what condition is required? Okay, so when it will be plus 5 volt, guys, what I'm assuming is the output is plus 5 volt. That means what I'm assuming, V plus is definitely greater than V minus, right? That is the condition I'm doing. I'm assuming that. Okay. So my question is, when the state of the output will change from plus 5 to minus 5. Okay. So when it will change from plus 5 to minus 5, when it will change. Okay. When it will change, when my V plus is nothing but Vx will be less than V minus, implies Vx is less than 0, right? Here V minus is 0, right? So how it will happen? First you see this voltage Vx. I put a nodal equation at point node X. Vx minus Vin by 1k plus Vx minus V0 by 1k is equal to 0. Okay. Simplice. What is Vx? 2Vx. Okay. Is equal to V in plus V0. Right. Simplice. Vx is equal to V in plus V0 by 2. Right. Okay. So what I am telling, so let's go to the next page. Vx is equal to V0 plus V by 2. Okay. So what I am telling, now my output is plus 5 volt and it will change to minus 5 volt at what point? So it change to minus 5 volt when Vx will be, right, less than 0. Right. That is V positive will be less than V negative. Simplice V0 plus V in by 2 is less than 0. Simplice V0 will be less than V in, right, minus V in, right. That means if okay, simplice V in is less than minus V0. This implies V in is less than minus 5 volt now. Okay. So if my V0 is 5 volt, okay, when my V in will be little less than minus 5 volt, my output will changes from, this is the condition, my output will change from plus 5 volt, okay, to minus 5 volt. Right. So if my initial assumption is right, V0 is plus 5 volt, to go to minus 5 volt, I need my input voltage should be less than minus 5 volt. Okay. Now, suppose my output is now minus 5 volt. Now, if I want my output to switch from minus 5 to plus 5, when it will happen? Presently, my output is minus 5 volt. Same equation, Vx for output switching to 5 volt from minus 5 volt, and Vx should be greater than 0, right? V positive is greater than V negative, then only my output will be plus V saturation or plus 5 volt. This implies V0 plus V in by 2 is greater than 0. This implies V0 implies V in is greater than minus V0 is equal to, what is minus V0? Minus of minus 5 volt is equal to plus 5 volt. Okay. So that means if my output at minus 5 volt, if my V in is greater than plus 5 volt, the output will change from minus 5 to plus 5. Okay. So let me draw here. Okay. Suppose my output is 5 volt plus 5 volt, right? Suppose my output is plus 5 volt, the first condition. First condition is my output is plus 5 volt. Okay. Then it will go to minus 5 volt. When my V in, this is my V0, this is my V in. Okay. When my V in will be less than little 5 minus 5 volt, then so it's minus 5 volt V in. Then my output will change from plus 5 to minus 5. Become to minus 5. Okay. And it will go to minus 5 right? And it will stay in -5. Okay. Now, at what point my output will change to +5? If my V is greater than +5 volt. So it will stay here. It will stay here. It will stay here. If my V in goes little more than +5 volt, it will go to +5 volt and it will stay here. Right. So this is called hysteresis bit. Hysteresis. This is hysteresis. Okay. So I'm summarizing what is happening. My output will stay at +5 volt. When my input will go little less than -5 volt, my output will go to switch from +5 to -5. Again, my output will stay at -5. If I go on increasing my input in the direction, then when my input will reach to +5 volt, just after that it will go to +5 volt and it will stay here forever. Okay. So thing is, for switching my output state, I need either my V in should be less than -5 volt, or my V in should be greater than +5 volt. Okay. So for switching the output from +5 to -5, I need my V in should be less than -5 volt. For switching the output from -5 to +5, I need my V in should be greater than 5 volt. Okay. So now you come to the question. In this question, you see the input is only plus or minus 1 volt. 1 volt. So that means it is in between here. Okay. So that means my input will not able to change the state. Okay. After switching on, if it is +5 or -5, it will stay at that same point, because for changing the state, I need either less than -5 volt or greater than +5 volt. Okay. Which my input is not capable of. Okay. So the circuit will stay at +5 or -5 after switching on, that I don't know at what voltage, maybe +5 or -5. Or if it stay at one state, it will not go to another state, because my input is not capable of going to +5 or -5. Okay. So the output will stay either +5 or -5. Any of the above, I do not know, or anybody do not know. Okay. So the constant either +5 or -5 is the answer. Okay. Second question is, in the circuit shown below, all the components are ideal. Okay. Vi is 2 volt. Okay. The I0 of the op-amp, okay, is asking in the question. Okay guys, you see, since the op-amp is in negative feedback, that means some part of output is fed to the negative terminal. Okay. So it obeys a principle called virtual ground. V positive is equal to V negative. Voltage at the non-inverting terminal is equal to voltage at the inverting terminal when the op-amp is in negative feedback. Op-amp is in negative feedback. Okay. So that means here I'm getting 2 volt. Okay. So now I have to calculate what is the output voltage. Put a nodal at this point. Okay. 2 minus 0 by 1k plus 2 minus V0 by 1k is equal to 0. This implies V0 is equal to 2 plus 2 is equal to 4 volt. Right? 4 volt. Now I have to put a nodal at the output V0. Okay. So let us put a nodal at the output V0. So nodal at V0. V0 by 1k plus V0 minus 2 by 1k minus I0 is equal to 0. Implies I0 is equal to V0 plus V0 minus 2. Since 1k, I can say 10 power minus 3 milliampere. Okay. Okay. So V0 is 4 plus 4 minus 2 milliampere is equal to 6 milliampere is the answer. Right? It's easy question. First thing is I have to calculate V0. If I calculate V0, I can easily calculate the current sourced by the op-amp. Okay. Okay. Let's move to the next question. The input is sinusoidal. It is asked to find out the steady state output voltage V0. Right. So guys, you see, this is a, I can say, voltage doubler. Okay, you might have studied voltage doubler. This is a voltage doubler. How it operates, let's see. First, you concentrate on this one. Okay, what will happen? Okay, I'm applying a sinusoidal waveform here. Okay, so minus. Okay, so during positive cycle, it will be off, right? But it will conduct during the first negative cycle. So it will conduct like this. Okay, so when it will conduct, okay, what will happen? The capacitor will start charging. Okay, and suppose this is my Vm peak voltage. This is my minus Vm. Okay, so the capacitor will charge like this. Okay, to Vm, the peak voltage of the sinusoid. Okay, now what will happen? After it charged to Vm, okay, now you see the voltage here. Voltage here is nothing but V in plus Vm. V in plus Vm is Vx. This is Vx. Vx. But in place, if I draw pictorially, if my input is a sinusoidal, right, of plus Vm and minus Vm, I am adding some DC voltage Vm. Okay, it will give me what? It will give me 2 Vm. Right? So here I am getting 0 to 2 Vm. Right? So now you see this Vx is a signal of 0 to 2 Vm sinusoid is applied to this particular circuit. Is called peak detector. Right? So the diode will be forward bias. Right? Diode will be forward bias. And the capacitor will charge. The capacitor will charge to what? To the peak value of the input. It is 2 Vm. 2 Vm. Okay. So in the next cycle, the Vx will be lifted by the potential Vm. So the potential will be varying from 0 to 2 Vm. When this waveform will be applied to the D2 and C2, the diode will be forward biased and the capacitor will start charging. Will charge to the peak voltage. It's 2 Vm. So my V0 is equal to 2 into Vm. Okay. Vm is the peak voltage of the input. Here how much? 2 into, what is Vm? 230 volt is the RMS. That means Vm is equal to 230 into root 2, right? Because I know Vm by root 2 is equal to Vrms of a sinusoidal waveform, right? So what is the answer? Let's calculate it. 2 into root 2 into 230. So it gave me 2 into root 2 into 230. It gave me 650.5 volt. Okay. So this is a voltage doubler circuit. What will happen? In the initial negative cycle, it will charge to Vm. Then in the subsequent cycle, what will happen? The Vx will be lifted by Vm. So it will vary from 0 to 2 Vm. When it will apply to this D2 and C2 peak detector, the capacitor will charge up to 2 Vm. Okay. So the answer will be 2 Vm. Nothing but 650 volt. Then go to the next question. 650.5. So guys, it's a 2-mark question. Okay. For the BJT in the amplifier shown below, base to emitter is 0.7 volt. KT by Q thermal voltage is 26 millivolt. Okay. Assume the output conductance is very, very high. That means assume that R0 is almost infinity, right? And base current is negligible. That means IB is 0, right? The capacitors are also assumed to be short circuit at the input signal frequency, right? When the input Vi is directly coupled, we have to find out the low frequency voltage gain V0 by Vi of the amplifier. Okay. So guys, you see here, in order to find out the voltage gain, okay, what it actually thing is, when Vin is not applied, okay, when Vin is not applied, okay, in DC, the capacitor is open, this also open, right? In DC, the capacitor C1 and CE are open, okay. Vin also is, so when Vin is equal to 0, not applied, okay, C1 and CE are open, right? Open. So in that case, what will happen? Suppose it is connected to ground. Okay. When Vin is not applied, it is connected to ground. Okay. So these are open. Okay. So there will be some DC current flowing through the circuit, right? That is IC here, IE. Okay. Since the IB is 0, the IC is equal to IE only. Okay. And my output voltage is V output is equal to VCC minus IC into RC. Okay, this will be my output voltage. So what will happen when I apply a input AC? What will happen? The IC will change. Okay, now the output I will get some AC. Okay, and we have to find out the magnitude of output AC to the input AC. Okay, so let's go step by step. First thing is I need to calculate the DC parameters. Okay, because the AC is superimposed over the DC. Okay, so initially the Vin is not there. I will just calculate DC. This is open. This is open. This is also open for DC. Okay, now you will put a loop here. Okay, what is that loop? 0 minus VB is 0.7 minus IE into RE. This is IE, right? This is IE. E into RE minus V is 10, minus 10. Equal to 0. This implies, okay, IE is equal to 9.7 divided by RE is equal to 20K. Okay, since we know IE is equal to IB plus IC. Emitter current is equal to base current plus collector current. It will be approximately equal to IC. Since IB is negligible, okay, is equal to 9.7 divided by 20K is equal to 9.7 by 20 milliampere. Okay, this is my collector current. Okay, now I have to go to the small signal analysis. Okay, and here I could know also my output voltage V0. V0 will be equal to VCC 10 volt minus IC into RC. IC is 9.7 by 20 milliampere into 10K, right? So got cancelled. I got around 0.3 volt, right? 10 minus 9.7 by 2. How much I got? 10 minus 9.7 divided by 2 is equal to how much? 10 minus 9.7 divided by 2. 9.7 divided by 2 is 5.15 volt. So, okay. So presently, when I did not apply any AC, the DC current flowing through the circuit is 9.7 by 20 milliampere, and the output voltage is at 5.15 volt. Now, when I apply input AC, what will happen? It will change my base to emitter voltage. Then this will change my collector current. Okay. Now my collector current will be IC plus small IC. Now I'll get a output voltage of little AC. Okay. So that I have to calculate using small signal analysis. Okay. So for going to small signal analysis, what I have to do? I have to replace this VCC to ground. These capacitors will be behave like a open circuit because for the input signal, the capacitors should be short circuited. Okay. So what I got, input is short circuited. Okay. And the all capacitors are shorted. Yes. My VCC will be grounded, right? The capacitors are shorted. Here also the capacitor is shorted. Okay. So this is my small signal equivalent circuit. So in this circuit, I am just interested only in the ACs or increments. Okay. So already DC is there, that I'm not interested. So I'm putting all DC to ground. Okay. And capacitors are shorted. Okay. Now if I draw the small signal equivalent circuit, what will happen? Between base to emitter, I have a resistance called R pi. The value will be Vt by Ib. Okay. And in the collector, the current will flow. Okay. It will be Gm into Vbe. Okay. What is Gm? In this class, Gm is IC by Vt. Nothing but Vt is Kt by Q. Okay. And this IC is nothing but my DC current. Okay. So we remember the small signal equivalent circuit parameters depend upon my DC currents, DC voltages. Okay. So here RPI depend upon DC base current. The GM depend upon my DC collector current. Okay. So and you see from collector to ground, I have RC. From collector to ground, you have RC, and also from collector to ground, I have RL. This is RL. RL. Okay. So this is the equivalent circuit of my amplifier, right? This is called small signal equivalent circuit. Okay. So now you see my V0 will be, V0 is nothing but the AC voltage at the output will be minus Gm into Vb is the current, right? Into the resistance is RC parallel to RL. Okay. Is equal to minus Gm into what is Vb? Vb is nothing but base emitter voltage is nothing but V in only. V in into RC parallel to RL. Okay. This implies V0 by Vin is equal to the gain is equal to minus Gm into RC parallel to RL. Okay. Now put all the values. Gm is minus IC is 9.7 divided by 20 into 10 power of 3 into Vt is nothing but 26 millivolt is given already into RC parallel RL. RC 10K, RL 10K. So 10K parallel 10K is 5K into 10 power of 3. Okay. You put all these values, how much you will get here? You will get approximately equal to, put in the calculator, you will get 89.42. Okay. So the gain is 89.42. Okay. How you have calculated? First calculate the DC current IC. Then after calculating DC current, build the small signal equivalent circuit. Then calculating gain is very straightforward. Okay. Gain depend upon my transconductance. Transconductance is nothing but IC by Vt. IC is nothing but my DC collector current that is flowing before I apply a AC signal. Okay. So this is the answer. So the next question is an enhancement MOSFET. Okay. having threshold voltage of 3 volt. That means VTH is equal to 3 volt. Okay, being used in the sample and whole circuit given below. Okay, assume that the substrate of the MOSFET is minus 10 volt. Okay, connected to the most negative potential, right? The input VI lies between plus or minus 10. Okay, the maximum value and minimum value of VG required for proper sampling and hold respectively. Okay, guys, you see how sample and hold circuit behaves. Just to see how it behaves, I have to apply a pulse waveform to the gate, right, like this. Okay, 0 to some voltage VG. Okay, so what will happen in sample and hold? When my gate is high, in the duration, the MOSFET will be on. Whatever Vin will be there, the capacitor will charge to that point. Okay, Vin will come here. Okay, now when the gate voltage goes to 0, in the duration, the capacitor, the transistor will be off, and whatever Vin will be there at this particular point, it will stay for whole duration, right? So it will hold that voltage. Okay, so during the time when my gate voltage is high, the transistor will be on, the capacitor will charge to Vin. Okay, and during the end of the point it is high, the value that will be stored in the capacitor for the entire duration when my gate is off. Okay, so it will hold the value when gate is off. Again, when my gate is on, it will charge to the new Vin. Okay, this is the process of sample and hold circuit. Okay, you see, for example here, my VI lies between plus and minus 10 volt. Suppose my VI is equal to 10 volt. Okay, so if VI is 10 volt, okay, when it will on, it will charge the capacitor up to 10 volt. Okay, so V0 will go up to 10 volt is nothing but V source, drain, gate, V source. Okay, when VI plus 10 volt, my capacitor will charge to plus 10 volt when my gate is on or my gate is high. Okay, so how much gate voltage I need for making it on? I need VGS should be greater than equal to VTH. This implies VG minus VS should be greater than equal to 3 volt. This implies VG should be greater than equal to Vs plus 3 is equal to 10 plus 3 is equal to 13 volt. That means the maximum voltage of VG should be 13 volt, right? And let's calculate minimum. Then V in is equal to minus 10 volt, right? At that time, my V0 will be also charged to minus 10 volt is equal to my V source. Okay, it implies to making it on, Vg minus Vs should be greater than Vth. This implies Vg should be greater than equal to Vs plus Vth is equal to minus 10 plus 3 is equal to minus 7 volt. Okay, so for the sample and whole circuit to function properly, the minimum and maximum value of Vg are minus 7 and plus 13. Right? So this is the answer. Okay, because my gate have to on. So it will on depend upon the how much input voltage I applied and how much my source voltage will go. Okay, and also it depend upon my threshold voltage. Okay, so let us go to the next question. So guys, using the incremental low frequency small signal model of the MOSFET device, calculate the Norton's equivalent resistance of the circuit. Okay, so what it want to calculate? It want to calculate the resistance looking from this source. Okay, the small signal resistance. Okay, so let us see how it will calculate. So for calculating the resistance, what you will put? Will put connect a voltage source, right, from source to ground, and if you know the current Ix that is flowing from this source, then my resistance will be Vx by Ix, right? So this is the resistance looking through the source. I connected a voltage source. I need to calculate the current flowing from this source Ix. If I divide Vx by Ix, it will give me my R equivalent. Okay, looking from the source. Okay, so for that, what you have to do? I replace the VDD to ground because I am only interested in increments. Okay, so let's replace the MOSFET by a small signal equivalent circuit between drain. This is nothing but circuit. This is my mistake. Okay. This is the source. Okay. This is drain. This is source. This is gate. Okay. Between gate and source, I have VGS. Okay. Source to ground, I am applying a VX. Okay. And the current will flow from drain to source, GM into VGS. Okay. And the output resistance is RDS. Okay. And I have a resistance from drain to ground. From this is drain to ground. Okay. AR. Okay. So in this circuit, I have to find out VX by IX. If I can find out, then I can know the resistance looking from the source. Okay. See what we can do. Let's this is ID. Okay. So this current will divide by these two branches. Again, it will come here. Right. This is also my IDS. Okay. So if you see in this node, okay, you see IX plus IDS is equal to 0. This implies Ix is equal to minus IDS. This is my first equation. Okay. Now let us apply a Kirchhoff's voltage law in this loop. Okay. What is this? 0 plus minus. This is minus IDS into R minus. What is the current? IDS was flowing. Then some current have gone through this branch. What is the current here? IDS minus GM into VGS is the this current, right? So IDS minus GM into VGS, right? Because ID current will flowing here, GM VGS flows through this branch. Remaining will be IDS minus GM VGS flowing through the resistor RDS. Okay. Again from here to here, I have minus Vx equal to 0. Okay. So now you see Vx is equal to, okay, minus IDS into R, okay, plus IDS minus GM VGS into RDS, right? IDS into R, ID minus GM VGS into RDS is my Vx. Okay, guys. What is VGS? If you see here, you put a loop in this equation. VGS minus Vx is equal to 0. Implies Vx is equal to minus VGS, or VGS is equal to minus Vx. Let's apply that. Minus IDS into R, okay, plus IDS into RDS minus GM into VGS. GM into what is VGS? VGS is nothing but minus VX into RDS, right? So let us take this GM VGX this side. That means VX into 1 plus this minus will go to plus GM into RDS, right? What I am doing, this total term with Vx, this minus minus plus, again minus, it will go to left side, become the plus GM Vx RDS. So I have taken Vx common is equal to minus into IDS into R plus RDS, right? This implies, and we know IDS is nothing but what? Already I know, minus Vx minus Ix. So let's replace this with minus Ix. Okay. So Vx by Ix is equal to R plus RDS divided by 1 plus GM into RDS. This is my answer. You see, this is my answer. RDS plus R by 1 plus GM into RDS. Okay. So it's very simple, right, guys? What I have done, I just put the small signal equivalent circuit. I put a KVL loop here, then just solved. Okay. You see, Vx is equal to IDS into R plus IDS minus GM VGS means the current through this is IDS minus GM VGS into RDS. Okay. And VGS is nothing but minus Vx. I put here minus Vx. Okay. And IDS is nothing but minus Ix. I put here. Putting this, you can easily solve it and you will get it. Vx by Rx is nothing but R plus RDS by 1 plus GM into RDS. The resistance looking through this source. Okay, this is a very great question. Okay, so in this circuit, the component in the circuit given below are ideal. Okay, R and C given 2K and 1 microfarad. It is asking to calculate the 3 dB cutoff frequency of the circuit. Okay, so V0 by Vi I have to do, and I have to see V0 falls by 3 dB at what frequency, right? So let us see. See guys, since the circuit is in negative feedback, right? That means some part of output is fed to the negative terminal. Okay, so it is obeying virtual ground principle. So voltage at negative terminal is equal to voltage at positive terminal. Here I get 0 volt due to the virtual ground principle. Okay. Now you see, let's apply, first calculate V0, okay, by Vn. Then I have to calculate at what point this V0 will drop by 3 dB. At what frequency? Okay, so the first step is calculate Vn, V0 by Vn. Then we have to see at what frequency my V0 is dropping by 3 dB. Okay, so let's put a nodal at this point. Okay, let be Vx. Okay, so nodal at point x. What is this? 0 minus Vn by R plus 0 minus V0 by R plus 0 minus V0 by 1 by SC, okay, is equal to 0, right? Now V0 into 1 by R plus SC is equal to Vn by R, right? V0 minus Vn by R, right? Because V0 by R, V0 by SC I have taken to the right side, it become positive. Here minus is remaining minus. Okay. This implies V0 into 1 plus SCR by R is equal to minus V in by R. This implies V0 by V in is equal to minus 1 by 1 plus SCR, right? This is my output by input. Okay, so if I see the magnitude of V0 by V in is equal to, if you put the omega, S is equal to j omega, right? 1 divided by 1 plus j omega C R. If I calculate the V0 by V in magnitude is equal to 1 by 1 plus omega square R square C square the root over, right? A square plus B square, right? So at what frequency this will be dropped by 3 dB? That means this will become 3 dB means become 1 by root 2 times, right? So that will give me 1 by omega square. Okay. If you do the squaring of both the side, okay, one going to get cancelled. 1 plus omega square R square C square is equal to 2. This implies omega square R square C square is equal to 1, right? So omega is equal to 1 by RC. This implies frequency is equal to 1 by 2 pi R into C. Okay. See what I have done? I have calculated V0 by V in. Then I have to know at what frequency omega it will drop by 3 dB means it will drop by 1 by root 2 times. Okay. Then if I calculate the frequency at which it become the 1 by root 2. Okay. The frequency comes 1 by 2 pi RC. So calculate the frequency 1 by 2 pi. What is the R? R is given 2K and 1 micro. 2 kilo into 1 micro. If you calculate, it will come to solve in the calculator 1 divided by 2 into pi into 2K into 1 micro. It will give me 79.9.57 Hertz. Okay. So the answer will be 79.57 Hertz. Okay. First calculate V0 by V in. Then at what point the V0 will be dropped by 3 dB. That means it will become 1 by root 2. Okay. Then it will give me the frequency. Then I can calculate the frequency is equal to 1 by 2 pi RC. Okay. I think this is the last question. Okay. You see, in the voltage regulator shown below, okay, VI is unregulated, input 5 at 15 volt. Okay. So VI will be 15 volt, but it is not regulated. There will be some variation. Okay. VB is 0.7. Assume base current is negligible for both BJTs. The output is regulated at 9 volt. Calculate the value of R2. Okay. See guys, then in steady state, okay, we'll get 9 volt at the output. This is a voltage regulator. Okay. How it will do this? Okay. When in steady state, what will happen? We'll get 0.7 volt here. Okay. And at this point, how much voltage will you get? 0.7 plus 3.3 will get 4 volt here. Okay. So I need to calculate what is the value of R2. Okay. That will make this output to 9 volt. Okay. So let's put a nodal here. Let it be Vx. Okay. Nodal at x. X. Vx by R2 plus Vx minus V0 by R1 is equal to 0, right? This implies Vx into 1 by R2 plus 1 by R1 is equal to V0 by R1. Implies V0 is equal to R1 will go this side, Vx into 1 plus R2 by R1. Okay, so I have to calculate what is the value of R2 that will make my output 9 volt. Implies V0 is 9 volt is equal to 4 volt into 1 plus R2 divided by 1k, right? So this is equal to 9 by 4 is how much? 9 divided by 4 is 2.25. 9 by 4 is equal to 1 plus R2 by 1k. This implies R2 by 1k is equal to 9 by 4 minus 1. 9 by 4 minus 1 is equal to 9 minus 4, 5 by 4. Okay. This implies R2 is equal to 5 by 4 into 1k into 1 is equal to 5 divided by 4 is equal to 1.25 kilo ohm. Okay. So thing is, when it is in steady state, okay, I'll get 0.7 volt here. Then this will be 3.3 volt is a general voltage. Okay. So I'll get 4 volt here. Then I have to calculate the value of R2 that will make my output voltage V0 to 9 volt. Okay. Just before leaving, I want to just give you how it regulates actually. Okay. Suppose my output is 9 volt. Okay. Suppose my input is little bit increased. Okay. What will happen? Instantaneously, what it will do? Suppose my V in will how it, I want to explain this. This is the answer 1.25 kilo ohm. Okay. Now the session is over. I just want to give you a feel of how it regulates. Okay. Suppose my output is 9 volt and input is 15 volt. Okay. Suppose my input increased. Okay. It increased. Okay. Then how the output is regulating. Okay. So what will happen? Suppose my V in is increasing. V in increase. What it will do? Suddenly it will increase V0. Right. Then when V0 will increase, what will happen to Vx? Vx will increase. When Vx will increase, what it will do? It will increase the base current IB1. Okay. IB1 will increase. If my IB1 will increase, what will happen to this voltage VB? VB is nothing but, if IB1 will increase, it will increase IC1 also. So it will increase IC1 also. Okay. Now, if IC1 will increase, what will happen to VB? VB is nothing but V in minus IC1 into R3. So what will happen to my VB2? This is VB2. Okay. VB2. VB2 will decrease. Then what it will do? It will decrease my IB2. What it will do? It will decrease my current IE2. IE2. What it will do? Is current decrease. What will it will do? It will decrease my voltage, output voltage. It will decrease my output voltage V0. Okay. So what I'm telling, if V increases, V0 will increase. Then it will increase the potential at Vx. Then it will increase the current IB1. Then it will increase current IC1. Then it will decrease the voltage VB2. Then this VB2 decrease will decrease the current, so that my output, which are already increasing, it will go on decreasing. Okay. So in steady state, we will try to maintain the V0 9 volt respective of my input variation. Okay. This is the way it is regulating my output in a closed loop. Okay. Suppose my V in will decrease. Okay. What will happen? Second, let us see. Like, suppose V in will decrease. Okay. What will do? V0 will decrease. V0 will decrease. Then Vx will decrease. Then IB1 will decrease. Then IC1 will decrease. Then VB2 will decrease. Then IB2 will decrease. Then IE2 will decrease. Then what will happen? Since the current decreases, what will happen? My voltage V0 will increase, right? So my decrease in voltage will be compensated by increase in voltage by the loop, right? So that's how the voltage will regulate. Okay, so that's all guys. Thank you for watching.